The objective of this lesson is to answer questions by interpreting box plots. In previous lessons, students have learned how to create and read a box plot. Students have learned how to find the 5-number summary in a box plot: the maximum, minimum, median, upper quartile or Q3, and the lower quartile or Q1. Today, students will extend their knowledge to interpreting box plots. This lesson relies heavily on student collaboration and conversation. Statistics are used to describe baseball teams and players. Here is a box plot that displays the batting average for two teams, Team A and Team B. Batting averages are calculated by the number of times a player hits the ball divided by the number of times the player is at bat. For example, if a player is at bat 10 times and hits the ball 3 times, then the batting average is 3/10, or it can be said the player is batting 300. This process is finding the mean of the data. Let's use the box plot along with the table to answer a few questions. Which team has a larger interquartile range? Team B has a wider range of the averages between the players. How does the median of Team A compare to the median of Team B? They are very close, but Team A is slightly lower. Which team has the most consistent batting average? Team A has the most consistent batting average because the range is smaller than Team B's range. Now let's use the box plot to answer a few more questions. Gardner has a batting average of 195 thousandths, or Gardner is batting 195. Which team is he on? The lowest batting average on Team A is 201 thousandths, or batting 201, so he couldn't be on Team A. He must be on Team B because the lowest batting average is 164 thousandths, or batting 164. If a player on Team A has a batting average in the top 25% of his team, what could his average be? Looking at the table and the box plot, the upper 25% is from quartile 3, which is 270 thousandths, and the maximum value, which is 303 thousandths. So his average would be between 270 thousandths and 303 thousandths. Campbell has a batting average of 200 thousandths. What would Campbell's ratio be of hits to the number of times he's at bat? The ratio would need to be any ratio equivalent to a ratio of 200 to 1,000. For example, 2 to 10, 20 to 100, or even 1 to 5, just to name a few. Let's look at one more box plot representing the percentage of free throws made of NBA teams in 2014 and 2015. The statistical question in regards to this box plot is, which year had a better free throw average? In comparing the two box plots, what comparison statements could be made about the box plots? 2014 was a more consistent year because the data is less spread out. However, 2015 had a higher median average. What comparison statement could be made about the interquartile range? The interquartile range is found by taking Q3, subtract Q1. 2014 would be 77, subtract 74, for an interquartile range of 3. 2015 would be 79 minus 75, for an interquartile range of 4. 2015 has a higher interquartile range of 4 compared to 2014's interquartile range of 3. So overall, the percentages of free throws made has improved because more shots were thrown accurately between around 75 and 79% in 2015, as compared to 74 and 77% in 2014. The objective for this lesson was to answer questions by interpreting box plots. We met this objective by comparing two sets of box plots for baseball batting and basketball free throw averages. We decided which box plot had a better set of data and used the 5-number summary to prove our thinking.